Hi everyone, welcome to the third day of AGU, Wednesday. I'm Christina Last. Now, I'm going to answer a few questions such as, what can satellite imagery tell us about air pollution from oil and gas flaring? And such as, can we use satellite imagery to actually measure the progress towards governmental objectives, such as the Kurdistani government's objective to phase out gas flaring by the end of 2023? So, if we want to answer these questions, let's first go through the context. So, where is Iraqi Kurdistan? Let's look at the methodology. How can we actually use satellites to identify these gas flares? And I'll talk a little bit about what gas flaring is and why it's a problem. And then let's look at the results. But most importantly, let's look at the impact on the ground. How can we use data and storytelling to actually talk to communities in the ground about the issues that they're having with environmental pollution? So first, the context. So let's skip ahead and let's look at the region. So northern Iraq, so Kurdistan is a region in northern Iraq. It's a resource-rich region. It actually has 45 billion barrels of oil and 25 trillion cubic feet of known gas preserves. So what we actually wanted to do is look at some of the locations in northern Iraq, Erbil, Kalak, Kawagosk, and Lalesh, and actually see what the impact of gas flaring was on these locations. Now, you might be thinking, what's gas flaring? Well, gas flaring is the process of burning off natural gas from oil and gas refineries. It happens largely around the world. Actually, in 2018, 45 billion cubic meters of gas were flared just alone in that year. And just to give you an idea of how much that is, that's the entire consumption of gas for Central and South America. So this is a massive problem. Why do people gas flare? It's a process basically when you can't, when it's not economical or secure to safely transport or store the gas, it just needs to be got rid of. It's a massive environmental problem. Stuff like methane can impact the wildlife, agriculture, and also human health. And we'll be focusing on the human health aspect in this story. So the methods, how do we go about identifying gas flares using satellite data imagery? So here we can see that we use ground data. So ground data is basically collected from something called SkyTruth. SkyTruth have known locations of gas flares, but they're very few and far between. But we want to basically associate the ground truth with satellite images. So we take a bunch of satellite images, such as nighttime light, temperature, and humidity, as well as other stuff like methane and NO2. These are pollutants that we know are basically going to show in the observed data. Then we use machine learning. So machine learning can actually help us identify the location of new gas flares, because we can read the relationship between the known locations and the satellite image pixels, and then take those images and see in unknown locations, can we actually observe whether there was a gas flare or not. And we can do that, and we can validate that using photos on the ground. So let's take a look at some of the results. So here we can see a map of the gas flares across the region. So if you look at the same variable from SkyTruth, you can see very few locations of gas flares. But when we actually take our algorithm and we look at the region in general, then we can actually observe a lot more. And we can see the gas flaring incidents going from all the way, this is a count of monthly aggregated count of gas flares. So we can see everything from 2 up to 12 gas flaring incidents per month. And we wanted to track this through time as well. So here you can see a graph, a long-run average trend, all the way from January 2019 up to today. And we can actually see the flaring phase-out date. So this is when the government wanted to actually start the gas flaring phase-out. And we can see up to today, they've managed to reduce the trend slightly, and we can see the seasonality. So in the winter period, there's a large amount of gas consumption, so gas flaring goes down. In the summer, the gas flaring goes up. It's not required. But we're not sure that they're going to be on track for the flaring phase-out at the end of 2023. So what about the impact? What about the storytelling? So we've been in contact with a large amount of press organizations in the area. One of our freelance reporters was live on WRT, the largest federal Iraq news outlet, sharing information about gas flaring and the impact of climate change in Iraq itself. In fact, Iraqi Kurdistan and the Kurdish dialect doesn't even have a word for climate change. So we want to be able to start establishing a dialogue in the communities about this. And we did this through publishing a piece with Rudal, the largest Kurdish news outlet, read by 3 million Kurds daily. And we actually also published a paper and a poster with Google Geo for Good conference as well. So bridging both the scientific and the press aspects of the research. Here's our team, me as the research lead, but also our lead reporter, Tom Brown, and our amazing 2 local reporters, Alana Travers and Stella, as well as members of our funding body, Environmental Reporting Collective, and our data visualization guru, Kang. So I want to say a big thank you to all of them, and yeah, welcoming any questions as well. Thank you so much. Yes. Yeah, so we actually published an open source tool. It's called Pollution Analysis Kurdistan, available on GitHub. And it ingests real-time satellite data. And then obviously with our model, we can then use the new incoming satellite data to predict the location of new flares. So we're actually running this analysis continuously in real time to see the changes in the flaring within the region. And we've not just built it for Iraq, it takes in global satellite data. So we're very interested in looking at other regions as well, such as Russia and other large gas flaring nations as well. Yeah. Thank you.